Hello there! In this tutorial we are creating Snake in Excel with Python, and we are using the xlwings module for that. Now, if you have never used Python in Excel, or if you aren't even aware that this is something you can do, let me give a brief introduction to Python in Excel. Essentially, you can control every part of your computer with Python, and Excel is no exception. In fact, Python has multiple modules that can do just that. The most popular one is called OpenPyXL, but that module has a crucial flaw. While OpenPyXL can create and manipulate Excel files, it cannot do it while the Excel file is running, which is why you cannot use it to create games in Excel with Python. xlwings, however, can do that just fine, hence we are using that one. And for the most part, xlwings does basically the same thing that OpenPyXL does. The modules are very similar. And by the way, you can also use Python to work with Word or PowerPoint. And I will make tutorials on that in the future as well. So get subscribed to not miss those. And for this video, I will assume that you have never used xlwings before. So the first part of this video is a brief introduction to the module. So if you already know the basics, I would recommend to skip that part. And the second part then creates the actual game. So with that, we can actually get started. And the first thing we need is to install it, which happens in the usual way, either in the PowerShell or on the terminal with pip. So pip install xlwings and then you should be good to go. And just in case you have come across it, there's also a paid version of xlwings that gives you a few more tools. But in our case, the free version is entirely fine to make the game. So you don't have to pay anything for this tutorial. So let's jump straight into the code and let's have a look at this. Here we are in a completely empty sheet of code. And the first thing we are going to need is to import xlwings. And to make it a bit easier to write, I have shortened it to xw. Now with that, we can use it. And if you run the code just now, you should not see any kind of message. So the code just runs and finishes. If you don't get an error here, you have installed xlwings properly. So that's a good start. So now we have to figure out how to actually use xlwings. And to fully understand how it works, we have to understand the basic terminology of Excel. And there are three major parts you have to understand. The most important one is an Excel book. And this is essentially a whole Excel file. And inside of this Excel book, you have multiple sheets. So if you look at the bottom of any Excel file, you can see multiple sheets. It's kind of like a browser tab, except for Excel. And then inside of every sheet, you have a whole bunch of cells. And this is where you store the actual information you work with. So we have to figure out these three parts: to get a book, to get a sheet, and from the sheet to influence the cells. And all of that is very easily done in xlwings. So let's have a look. Here I'm back in the code, and first of all, I want to create an Excel book. And this happens first with xw and then the keyword book. And here, make sure that you capitalize the first letter, kind of important. And now, if I run all of this, we should be getting an Excel file. And there we go. So this, you can literally tell in the top, is called book 1 Excel. So this is the book we have just created with this line of code. Now be aware, if you have a slow computer, creating this might take a couple of seconds, so be patient. And now at the bottom of this file, down here, you can see sheet 1. So what we have to figure out now is how to get from this book 1 to this sheet. And that is also very easily done. Let me close all of this. And the first thing I have to do is to store this book inside of a variable, which, well, happens in the usual way. So now I have this book available in a variable. And what I can do now is to type book and then dot sheets. And this is going to return all of the sheets inside of this book. So let me actually print the entire thing. And let's see what this gives us. And it's going to take a second, and there we go. So what we can see in here, we get our sheets. And inside of that, we have a list. So this list here. And right now, inside of our list, we have only a single sheet. And that's this sheet here. And you can see the name, in the final part. So this part here is the name. Then we also know that this sheet is inside of book 1. So that's this book 1 up here. And then, well, this is a sheet. But the really important information here is this sheet. That's what we actually want to get. And essentially, all we really have to do to get the sheet. Let me remove the print statement. So right now we know we have a list with only a single item inside. So what we can do is get the index 0 and store all of this inside of another variable that I've called sheets. And now if I print that, so print sheet, run all of this again. Now we can see that we have sheet book 1, sheet 1. So now we have access to this sheet. And this actually allows us to make some changes. So for example, what we can do is change the name of the sheet. So sheet.name, and in here, you just have to add a string. So in my case, let's call it test sheet. And now let me run this again. And now in the bottom of this Excel file, you can see test sheet. So we have renamed this sheet. Let me close it again. So with that, we can actually start to influence individual cells. And for that, we have to first figure out how to target one cell. And xlwings has a ton of different ways of doing that. Now, first of all, I want to get my sheet again. And now I can basically do something that looks very similar to indexing. So I want square brackets. And in here, we can add a string that is a letter and a number. Let's go with A1. And this would give us the cell A1. I'm going to show you in a second where that is. And now we can give this cell a value. So let's give it a value of my cell. And if I run this now, we have to wait a second again. And let me scroll in a bit to see this better. Now you can see we have the cell A for the column and 1 for the row. And inside of that, we have my cell. So this is what this A1 here means. That the A or the letter is for the column and the number is for the row. And if you have ever used Excel, this should feel quite natural. For the columns, you have letters, and for the rows, you have numbers. And I guess if you come to this from Python, there's one small complication. That Excel starts counting from 1. Whereas in Python, we always start counting from 0. This can occasionally be a little bit confusing, so just be aware of that. But alright, so with that, I don't want to save this. We have one basic value. Now what we can also do is, let me copy all of this. We can also target a whole field of cells. And this you do by adding a double colon and then the end cell you want to target. So let's say in my case, I want to go with D3. And let me add some different texts. Let's say just AAA, just to have something. And if I run this, we can see, let me scroll in a bit again. So now we have filled a couple of fields with one string. And our first cell was A1. The A1 we already have here. But then we went to D3, or this D3 here, which turns out to be this cell here. And then essentially what xlwing does is it goes from the start to the end and fills the entire field with whatever we want to fill it with. This could be a string, it could also be a color. We'll see that in just a second. Now let me close all of this again. And there's one more thing that you could be doing. And that is, instead of a string, you are passing in here a tuple. Let's say in my case, let's go with 3 and 7. And for the string, just to have something, let's go with BBB. And if I run this now, we can see, if I scroll in a tiny bit, so this is giving us the cell BBB in the column H and the row 4. And this might seem a little bit weird that our coordinates right now are 3 and 7. So how is this getting us H4? And well, let me explain. Essentially, the first number is the row and the second one is the column. And let me use a different color for that. And let's start with the row. And the problem we have here is what I explained earlier, that in Excel we start counting from 1, whereas in Python we start counting from 0. So essentially what we have done in the Excel file is that this would be 0, this would be 1, this would be 2, and this would be 3. So if we add a 3 in here, we get row number 4, which, well, is kind of confusing, but, well, it's a different ways of counting. So this 3 here is essentially just the row. And then the second number is for the column. And this one is a bit easier. So it would be 0, 1, 2, 3, 4, 5, 6, and 7. And this would then get us H. And if you combine those two, we get to B, B, and B. And that way you can also use tuples to get individual cells. So with that, we can target cells and change their values. Now, xlwings has a ton more ways to do this. The one you probably see a lot is called sheet, and then the method range. And in here, you can also add a 1, just like we have done up here, and then give it a value, and this value, let's call it CCC. And if I run this now, we can see in the top left, we have CCC. So the range method is also very powerful and does kind of the same thing we have seen with the indexing approach. Although it does work in slightly different ways, but they really don't matter all that much to us. So let me close all of this again. And for the game, I am not going to use this approach, but you are going to see it quite a lot online. So be aware of that. Now for the actual game, there's one more thing we are going to need that's really important. And that is how to change the color of a cell. And that is actually happening in a very similar way. So first of all, we are going to need a cell again. So let's say in my case, I want to get cell, let's say E1. And now instead of the value, I want to change the color. And for the color, we need what is called an RGB tuple. And literally all that means is that we get the amount of red, the amount of green, and the amount of blue. And then we mix these 3 colors together, and that gives us a color. And the value can go from 0, which means no amount of that color, or 255, which means the full amount of that color. So if I add 255, 0, and 0, we should be getting a red cell at position E1. So let's try this. And there we go. At cell E1, we get a red cell. So let me close this again. And now if I change this to, let's say, a 0 and a 255 and a 255, we would get no amount for red, all of green, and all of blue. So if I run all of that, we should be seeing a very bright blue or turquoise, whatever you call it, doesn't really matter. So this is then all we need for the basics. Although be aware, this is a really basic introduction. In fact, we are going to see a couple more things in the actual game. But for now, this is a pretty good start. But with that, I guess we can go into the actual game. And for the actual game, I will put this into 2 separate parts. The first part is all about setting up the board. So all of this is going to be static. And then only for the second part, we are going to add a moving bit that is, well, a video game. And for the second part, we are going to need a fair bit of game logic. So let's leave this one for now. And let's start by setting up the main board. And let me go through what I want to do in here. Essentially, I want to create 2 sections. One section is the actual game where the snake can move in. I call this one the game cells. Then below that, I am also going to add control cells. And in there, we have our control buttons and our exit button. And these buttons also have to be placed by us. And if you have paid attention in the first part of this video, setting all of this up shouldn't actually be all that difficult, although it might require some tinkering. But I guess let's go through it together. Here I am back in a completely empty sheet of code. And the first thing I want to do is to import xlwings as xw, just like we have done before. And now we have to create the book. But since I have to move around quite a bit of data, I want to put this entire game inside of a class, which is going to make our life significantly easier down the road. And inside of this class, I have to define an init method. And in here, as always, we need self. And besides that, I want 3 more parameters. The first one is the speed. So that's how fast our snake is going to move. And besides that, I want width and height. And these 2 parameters are going to give us the width and height of our game field. So the area the snake can move in. And well, with that, for now, let's just keep a path in here so we can create an actual instance of the snake. So let's call it snake. We need snake, and here for the speed, I want to go with 3. And for now, let's create a smaller field so it's easier to test. And I want this to have a width of 4 and a height of 6. And if I run this, nothing should happen. So the code runs, but nothing else happens because we are not showing anything yet. But that we can work on now. So let me get rid of this. And let me add a comment to explain what we are doing in here. And the first thing I want to do in here is the book setup. And essentially, I want to, number 1, create a book. Number 2 is select a sheet. And then number 3 is rename the sheet to snake. And this I want you guys to do as an exercise. So create a book, select a sheet, and rename that sheet to snake. Let's go through it one by one. And let's start with the book itself. And in here, this should be an attribute. So this has to be self. And I've just called this book. And to create a book, we need xw dot. And now with that, if you run my code now, we should be able to see an Excel file. There we go. This is already working. Nice. Now, next up, I want to select the sheet. And this also needs to be an attribute. So self.sheet. And in here, I want to get my self.book.sheets and then just get the one with the index 0. So this would then give us the sheet. Now finally, I want to rename the sheet with self.sheet.name, and I've called this snake. So now let's try all of this, and we can indeed see at the bottom we have snake. So I can close all of this, and this is then giving us our first part. Now next up, I want to add another section, and I've called this one the board setup. And then here we are just storing some general game variables. The most important one is self.speed. And for now, this is just going to be speed, although we are going to change this later. Now next up, I need my width, and this is just my width, and my self.height, and this is just going to be my height. So I know how wide and how high my game field is going to be, and I can use this all throughout my class. And with that, I can actually start setting up the game board. And this is going to be quite a few lines of code. So I'm going to put all of this inside of a method. And I call this board setup. So let's create this method. So self.board setup needs self and nothing else. And now in here, we have to find a couple of different things. So let me add a pass in here for now, and let me explain this straight in the Excel file. So here we can see it again. And essentially what I want to do for the cell, I first have to find the top left cell. And in my case, this will always be B2. So this cell here is always going to be our top left. Now this I've done to have a bit of an offset between the left and the top of the field. So we don't have the game in the top right. That looked a bit weird. So this B2 cell we always have. But from that, we have to get our width that is flexible and our height that is flexible. So essentially, we have to combine these two and get a cell that is essentially, let's say in this example, somewhere here. And finding this cell from this width and height information is going to require a few lines of code. But in the most basic sense, all we are going to do is we are getting the entire alphabet, so all of these column letters here, and then select the one that has the right index. So in our case, this would be 4. And then for the rows, all we really have to do is get the actual number here, and from that, select the right row. So these two parts we have to figure out. Let me close all of this, and let's go through this one by one. And first of all, I want to put all of this in a variable that I called game cells. And essentially, what we are going to create in here is what we created earlier. So a string that always starts with B2 and then goes to some other cell. Let's say in this case, just for the sake of the argument, it would be E5. And right now, this coordinate would be wrong. So we have to figure out how to get from a game width of 4 and a height of 6 to the actual coordinates of the final bottom right cell. So let me get rid of this. And instead, I want to turn this string into an F string so we can run code inside of it. And now I need some curly brackets. And this curly brackets is going to be for the column. So we need to figure out a letter. And to figure out the letter, we first need access to the alphabet. And Python has an entire module for that. And that module is called string. Although I don't really want all of the string module, I just need one specific part. So let me not import all of it. Instead, from string, I want to import what is called ASCII with a double E and then uppercase. And let me actually print this. So print ASCII uppercase with proper brackets. And if I run this now, and we're getting an error because we have to add some code inside of our F string. So for now, let me just keep it at E5, so it's working. And now for the uppercase, we get all the letters of the English alphabet in uppercase letters. So this is literally all that this one here is doing. So I can close this. And now we can actually start working in our F string properly. So essentially, all I want to do, I want to get my ASCII uppercase letters. And from that, I want to select the letter with the index that corresponds to the width of our game field. So 4 in our case. And well, literally, all we have to do for that is add self.width in here. And let me actually demonstrate what this is going to do. So print game cells. If I run this, we get from B2 to the column E. So if I draw this, let me scroll in a tiny bit, our top left cell is always going to be B2. So this would be one cell, then we have cell 2, 3, and 4, and at cell number 4, we get to column E. So we already know that this line here is working quite well. So that is a really good start. Now I can close this, and now we have to find the row. And this is just going to be another curly brackets. And in here, to figure out the row, we just need self.height. And well, let me run this now. And we get E6. And let me scroll in a tiny bit to draw this in a bit more detail. There we go. So as always, we are starting with B2. That's always our top left. And right now, our field would go to E and then to 6. Now, the problem is that for the column, we do indeed get 4 cells. So we get 1, 2, 3, and 4. So the width of our game already works just well. However, for the height, we do have a problem that we have 1, 2, 3, 4, and 5 cells only. But in our game, we specified that we want 6 different cells. So in here, we have a problem. And the reason is, again, what I talked about earlier, that in Python, we always start counting from 0. But in Excel, we always start with 1. And this is what causes the offset here. But, well, that is very easily fixable. Literally, all we have to do is to add a +1. So now if I run this again, and let me scroll in a bit as always. So here again is our start cell. And now we go all the way to this cell here. So we have 1, 2, 3, 4, 5, and 6 cells. Exactly what we specified in the height of our game. So this is now also working really well. And well, with that, we have the dimensions of our game. So now what we can do is fill the entire thing with a color. For that, we are going to need a color. And I have predefined a couple. So let me paste them in. Let's do it right before the snake. And then here we have all the colors we will need for the game. And for now, the board color is the actual color of the game board. Well, that makes sense. So essentially, I want to fill all of these cells here with this color. And this, I think, could be a pretty good exercise for you. So select all of the cells we have for now and fill them with the board color. All right, so essentially what we have to do. First of all, we need this self.sheet. So let me copy it. And now I want the indexing operation and I want to get my game cells. Now, next up, I want to specify the color. And the color should just be the board color. So we just want to target this variable here. So now let me try to run all of this. And we can indeed see a color for the fields. Now, obviously, right now, this field is going to be way too small. But later on, we can make this much larger. But for now, it is much easier to see what we are doing in a small field. Now, next up, we are going to need our control cells. And this is going to be another string. So we have a start cell and an end cell. And I guess let me demonstrate what this is going to mean in Excel. So let me scroll in a bit again. And essentially what I want to do, that here I have my entire game cell, and right below that, so starting from this cell here, I want to have a control panel. And this control panel should be 5 cells high. So 1, 2, 3, 4, and 5. And it should also cover the entire width of our game. So this wide. And as a consequence, we have to figure out 2 cells again. First one, this cell here, which right now would be B8. And then the other cell is going to be the one down here. And this one right now is going to be E12. So let me close all of this and don't save it. And I want to go from B8 to E12. So now we have to figure out how to create this number dynamically depending on the size of our game field. And there's one thing we already have, and that's this B again at the beginning, because our field is always going to start in that row. However, everything else we have to figure out one by one. So let's start with the height of our starting cell. And again, we are going to use F strings for that. And this could actually be a pretty good exercise for you. Try to figure out the top left and the bottom right cell so that you always have the full control panel that is 5 cells high and as wide as our game cells. Now, first of all, we have to figure out the top left cell and specifically the row here. And this one is actually quite simple because all we really need in here is to get this cell and go one further down because the control cells are right below the game cells. So I can literally just copy all of this, paste it in here, and change this +1 to a +2. And that is all we needed. Now, next up, we have to figure out the column and the row for the final cell. And this also isn't all that difficult because the width we also already have. And that is because our control cells and our game cells have the same width. So we can just paste all of this inside of here. So all I'm going to do is copy all of this, paste it in here, and we should also be good to go. Now, finally, we have to figure out the final row. And for that, it's important to remember we always want to have a height of 5 cells for the entire control panel. So literally, all I can do is copy all of this and paste it in here. And now instead of +2, I want +6. And now this should be all we needed. And as a matter of fact, let's go with self.sheet, get my control cells. And for now, let's go with value is equal to, let's call it control. And now let's run all of this and let's see what we get. And this is looking pretty good. And let's count what we got here. So this is our top left cell. We have 1, 2, 3, 4, and 5 cells in the height. And the entire thing is as wide as our game cells. So all of this is looking really, really good. And I guess there's one thing you might be wondering about. Let me move all of this to the side. Here's good. So you might be wondering, why did we have self.height +6 for this final cell? And I guess the answer here is that when we specified this self.height +2, so this cell here, we already included this cell. So this would be 2, 3, 4, 5, and 6. And this is where this 6 is coming from. And if we added a 7 in here, we would have gone down all the way to this cell, which is what we didn't want. So now I can close all of this. And we already have our cells. Now, next up, we need the actual buttons. And again, let me add some comments to explain a bit better what we are doing. So this would be the background colors. And next up, I want to get my buttons. Oh, and I did forget, we should change the value to a color. And the color we do want to get is the control color. So I just want to copy all of this and paste it in here. And now let's run this. And this is looking significantly better. And I guess while we are here, let's actually talk about the buttons. So for the buttons, I want to have 5 different buttons in total. The easiest one is the escape button, which shuts down the entire game. And this one should be in the bottom right. So let's call this one the exit button. Now, besides that, I have 4 direction buttons. And let me just draw in here where I want those to be. So this one here should be left. Then there is up. Then there's right. And then there's going to be down. And let's talk about the positioning here. Now, the exit button is always supposed to be in the bottom right of the control panel. So if we were to expand the size of this control panel, the exit sign would always be in the bottom right. Now, besides that, for the directional buttons, so these 4, I always want to have a 1 cell offset from the top and a 1 cell offset from the left. And that makes the game look a bit more open. So this is also something we have to figure out. Now, that being said, other than that, the position of these 4 buttons is pretty fixed, because we always go from a directional point of this B2 point, which stays constant, because this is always the top left of our cell. And because of that, we always know, for example, that this left is going to have the column C. And the up and down are always going to be in the column D, and the right one is going to be in column E. So this way, we already know the columns for each of the buttons, but we don't know their rows. This is something that depends on the height of our game field. So this is something we do have to figure out. But the columns we already know. And we know this because, well, the game always starts in the top left, and we have a 1 cell offset from that, and then we have our buttons. So this is going to make our life a fair bit easier. But alright, that was a lot of talking. Let's actually go through this. And I guess let's start with the exit cell. That should be one of the easier ones. And this has to be an attribute, so we can target it throughout the class. And I've called this one exit cell. And in here, again, we are going to need an F string with the position. Although now things are a little bit easier because we only want a single cell, we don't want an area. So we only need a column and a row. And actually, we already know the position of both of these cells. And this could actually be a really fun exercise for you. Try to figure out the position of this final cell that is in the bottom right of our control cell. And this is something we have already talked about in here. So pause the video now and try to figure out this position. The answer here was actually really easy, because in this control cell, we first figured out the top left cell of the control panels, and then all of this was the bottom right cell. And that is where the exit button is supposed to be. All I have to do is copy all of this, paste it in here, and we are good to go. So now what I can do is self.sheet and get self.exit cell, and now set the value to, let's call it quit. And now if I run this and I zoom in a bit, we get the word quit. Now we do have to change the color of the text and of the background. We're going to do that in just a second. But for now, we know that this is working. So that's a pretty good sign. Let me close this again. I don't want to save it. Now next up, we have to get the direction cells. And well, that is going to become quite repetitive. So let's go through it one by one. The first one is the left cell. And this one, again, is going to be an F string. And in here, what I mentioned earlier is we always know the start column. In this case, it's going to be C. And now for the row, I essentially want to have the top of our control cell, so this part here, and from that go 2 cells down. So, well, all I have to do is copy all of this and change this 2 to a 4. And now I can do essentially the same thing I've done earlier. So let me copy all of this and change the exit cell to a left cell. And the value here should be left. And now if I run all of this, that looks pretty good. So I know that this left cell is right in the middle of our control panel, and there are 2 cells on top of it. So this seems to be working quite well. Now next up, my up cell should be here, my right cell should be here, and my bottom cell should be here. And that way we would be getting a proper cross. So that's the next thing we have to work on. And I think this could be a pretty good exercise for you as well. So try to get the cells for up, right, and bottom, and fill them with the right text. It's going to be done in exactly the same approach I have done for now. All right, let's do it together now. And really, all we have to do is let me copy the left cells, and I want to change left to right. So this should be now right. The text should also say right. And now we have to figure out how to change this position to get 2 cells further to the right. And that literally just means changing this letter from a C to a D to go 1 to the right, and then to an E to go 2 to the right. And the row is still the right one. So now, this is also looking pretty good. So we have the position of the left cell and of the right cell. So that's all we needed here. Now, next up, we have to get the buttons for up and down. And let me copy these cells again. And this is going to be changed to up. That's looking pretty good. Cool. So now I have to figure out this string here. And well, first of all, the column we want to get right between C and E, which is the letter D. And next up for the row, we want to get 1 up. So this +4 should be a +3. And now let me run the code, and that's also looking pretty good. So now we start to have a proper cross for our game. And then finally, let me copy all of this one more time. We want to get the down cells. And this is going to have essentially the same position as the up cells, except on 2 rows further down. So I changed the 3 to a 5. And now, run all of this. We have a proper cross-like gamepad kind of thing. And we also have our quit button, so that's the position of all of our buttons. Now that we have that, we have to add the button styling. And for the button styling, we have to change two things. We have to give each of the buttons a background color, and this we already have. It's the button color here. And we also want to change the text color of each of the buttons, and that would be the text color here. So these are the two things we have to target. So essentially, all I'm going to do is I'm going to cycle through all of these different cells and then change the color for each of the cells and also the color for the text inside of that cell. So let's go through it one by one. First of all, we need a for loop. So let's call it for button in, that's going to be a list. And I just want to get all of my cells. So I want my exit cell, I want my left cell, I want my right cell, then I want my up cell, and finally my down cell. And now inside of that, I again need self.sheet and now the button. And first of all, I have to change the color of the cell. And the color I want is the button color. Now let's run all of this and see how it looks. And that's already a massive improvement. And besides that, I also have to change the color of the text. And that, let me copy this line here, that we can achieve with .font.color. And in here, I want to have my text color. And if I run this now, this should give us white text. And there we go. So this is looking significantly better. And right now, all of this looks really cramped up. But once we increase the size of our field, this is going to look significantly better. Actually, let's do it right now. So let me close all of this. And now I want to change the size of our field to make it actually look like a decent game. And in my case, I went with a width of 12 and a height of 8. And now if I run this again, so now we can see we have our buttons in the top left of our control panel and the quit button in the bottom right. But now we have one more problem for the styling, that all of our game cells are way too wide and not high enough. So that's also something we have to work on. So let me close all of this and let me add another section in here. And that's going to be the, let's call it cell dimensions. And to change the dimensions of a cell, we first have to target a cell. And let me just target a single cell just to illustrate this. So self.sheet and B2, so our top left cell. And now to change the width and the height of that cell, what we need is either the row height, and this needs to be an integer. So let's say for now with 40. And if you want to change the column width, we need, well, the column width. Spelling this correctly would also help. And let's go through them one by one. Let's start with the row height. So if I run the code now, this row should be significantly higher. And there we go. Now the row with B2 is drastically taller than all of the other cells. Now, what we can also do is for the column width, let's set this to a really high number so we can tell what's going on. Let's set this to 100. And there we go. Now the cell B2, or rather the entire row for B2 and the entire column is really large. So one important thing here to consider is if you change the row height or the column width of any cell, you change the entire row or the entire column. So be aware of that. And what is important here? Let me demonstrate this by only working on the row height for now. Technically, what we could be doing in here is adding in our game cells. So what we created earlier up here, our entire game field. We could set this one up like this, run the code now, and this would be working. The problem is this is also very, very inefficient because essentially what we do, we look at this cell here and we set the row height to something like this. Then we come to this cell here and we set the row height again to the same thing. Then we are doing the same thing for D, E, F, G, and so on. And for every single one of these, we are performing one operation that we didn't have to do. And I guess along with that, we are ignoring our control cells as well. So let me change the code here a tiny bit. And instead what I want to do is to only get my column B and then get the entire height of our game panel. So we essentially want to go from B2 all the way down to B14. And this is also not a particularly difficult thing to achieve. So let me get rid of all of this. And in here, I just want to have a string. And the string is always going to start at B2. And now we want to go to the end of our control cells. And this is an information we already have. It's literally just this self.height plus 6. So I can copy all of this, paste it in here, turn this into an f string. And now, if I run all of this, we are getting an error because, let me close all of this. The error here is that I forgot the capital B. And now let me try this again. And there we go. This is looking pretty good. So essentially, what we have done in here is that this B2 is very easy. It's just this cell here. But now for the second information, let me use a different color for this. We are still staying in the column B. So we're staying in here. And now we go all the way down to the bottom of our control panel. So we go all the way down to here. And then we are changing the row height for all of these cells. And that way, the next cells are normal sized again, which makes the entire game field stand out quite nicely, which is what I kind of like. Now, alternatively, something I didn't mention earlier, let me copy this line. What you could have also done is to select every single cell inside of this column. And this you would have done with the string B and B. So this way you're selecting all of the cells inside of this column. So if I were to run this, you would get literally every single row would always have the same height. Now in my case, I don't want to do that, but well, you could. Okay, so with that, we have a proper height for our row. And I'm actually quite happy with the height and the width now. So I'm not going to manually set the column width. So with that, we have set up our entire field. Didn't actually take all that long, although it was quite a bit of logic. So with that, we have to start working on the actual game part of this game. And this is going to involve a couple of things. So we have to place a snake, we have to place an apple, we have to get user input. And then once we have all of that, we have to move the snake depending on what user input we are getting. And then if the snake hits an apple, we have to make the snake larger. And if the snake hits either the end of the cells or itself, we have to crash the game, which in our case means we are just closing the Excel file. So that is going to be quite a few different things we have to work on. And I guess for now, let's start working on placing the snake and the apple and displaying both of them. And let's do all of that straight in code. So here we are back. And in my init method, I want to add another section. And this I have called snake setup. And in here, I want to create a couple of attributes. The first one I called self.body. And this is going to be the body of the snake. And this body is going to consist of individual cells. In the beginning, it's always going to be 3. So I just want to have a list with different cells. So essentially, for example, one body part could be something like, let's say B2. So this would be then one body part of our snake. But in here, we do have a problem because later on, I want to update the position of each body part. And then having something like B2 is going to be quite a pain to update. So instead, I am not going to use the string arguments, and instead, I'm going to use the tuples. So I want to place one body part of the snake, for example, in row 3 and column 4. And that way, I can just add a +1 to this part here, and then move this cell one row further down. And that is going to make the math significantly easier. Now with that, I have to figure out 3 body parts of the snake. And let me actually display the game again so we can see what we are doing. So essentially what I want to do is I want to place the snake when it starts right in the middle of the game field, somewhat to the left. So really all I'm going to do is I'm going to get the entire width of the game divide it by half, and then take the integer of that and place the snake wherever that happens to be. And then I guess give it a few pixels offset to the right, and then we should be good to go. Shouldn't actually be all that hard. So I want to get a tuple again, and in here I have to get the row and the column. And for the column, we can just use an integer. Let's say for the first part, let's go with a column of 5. And now for the row, I want to get my height and divide this by 2. The problem now though is that right now our height is 8. So if we divide this by 2, we would get 4. But if our height was 9, we would get 4.5. And then we would get an error because we have to use an integer here. So let me put this back. I have to turn this height argument into an integer. And well, with that, we have one cell of our snake. Now, all I really want to do is to copy this 2 times and then change the column. So this one here should be 4 and this one here should be 3. And with that, we have the body parts of our snake. They are not visible right now, but that comes in just a second. Actually, let's do it right now. And I'm going to do all of this in a new method that I'm going to call display game elements. That seems like a decent name. And in here, literally all I'm going to do is I'm going to cycle through every body part of the snake and then draw that part of the snake. So it's literally a pretty simple for loop. So let's say for cell in self.body, and in here self.sheet, and then we want to get the cell and change the color to, I put this as body color. And that is literally all we needed. So now in our snake setup, I can run self.display game elements. And if I run all of this, we can see our snake. So this is looking quite good. Now there's one problem we have right now, that the color of the head should be different from the rest of the body. So it's a bit easier to tell where our snake is going. So let's work on that. And I actually have a body color and a head color. And now we have to figure out where the head of the snake is going to be. And this actually isn't all that difficult. So if you look at the list of our snake body, in here we have 3 elements. So we have 0, 1, and 2. And well, the head is always going to be the list item with the index 0. So as soon as we know the index of each of these items, we can always tell which one the head is going to be. It is always going to be index 0. And the index in a for loop we can get with the enumerate method. And this one is going to return an index and then the actual information. So now in here, all I need to check is if index is equal to 0, then I want to do something else. And if that is not the case, I want to fill the sheets with the body color. And if we have the head, let me add the proper indentation. All of this code is still fine, but now I don't want the body color. Instead, I want the head color. So I can just replace this. And now let's run the code again. And there we go. Now our head has a different color. Or more precisely, inside of this list, the item with the index 0 is going to have a different color than the rest of the body. So really all you have to understand here is that this cell is this head with the index 0. And next up, I also want to have an apple. And the apple I also want to draw inside of this method. So I have to create the apple before I run that function. And to create the apple, we need a couple of lines of logic. So I'm going to create a whole new method that I called createApple. Let me create a whole new method, createApple. We don't need any arguments. And in here, we have to do 2 things. Number 1 is we have to get a random cell inside of our game cells. And this would then going to be the position of our apple. However, we also have to check that this apple isn't being spawned on top of the snake, because that would be kind of weird. So we have to first get a random cell and then check if this cell isn't on top of the snake. First of all, I want to get a random cell. And I want to get a random row and a random column. And to get random numbers, we need another module. So from random, import randint. I want to get a random row and a random column. And for that, I need the randint module, and in here get a start cell and an end cell. And this I have to do for both the row and the column. And now here we have to think about what numbers we are going to get. And well, the start is actually the easiest part because they're both going to be 1. So 0 and 0 would be the top left of the Excel sheet, so A1. But in our case, the game always starts in B2, which in a tuple would be 1 and 1. So the start part is always very easy to get. And well, for the end part, it's also not that much more difficult because we just want to get self.width or self.height. Or more specifically, the numbers we passed in here earlier. That's literally all we really want. So with that, we already have a random position. And now technically what we could be doing is just get self, let's call it apple position, is going to be the tuple with a row and a column. And now once we have called that, we can, inside of our display game elements, let me actually add a proper comment. So this would be the snake display. And then before that, I also want an apple display. And for the apple, all we need is self.sheet, then get my self.apple position. And then I want to change the color to the apple color. It's going to be this. And now if I run this, this should be working. Except now we are getting something very strange, that our apple color is down here, which not ideal. And that isn't exactly what was intended. And the issue here is that I messed up the width and the height. So for the row, we want the height, and for the column, we want the width. And now let's try this again. And there we go. Now we have an apple in the top left. That's looking pretty good. Let's try this a couple of times. That's now an apple all the way on the left. And now we get the apple all the way on the right. And I don't know why the apple is always at the corner. That's a bit strange. Ah, and now we have another problem. So now you can't see the apple at all. So if I go up and down, you can't see it. And the problem is that the apple is somewhere right below our snake, which is actually a very happy accident because that's exactly the problem we have in this code right now. And that we are going to fix in just a second. But first of all, let me run this one more time. And now I hope the apple is somewhere. Yeah, now the apple is in the middle of the field. So we just got some weird random numbers. But all right, the problem we have right now, if we are spawning the apple somewhere randomly, there's always a chance that the apple is right below the snake, which would be kind of strange. So we have to account for that. So let's call this check if apple is below snake, or on top of the snake, or in the same position as the snake. Well, you get the idea. And in here, this is going to be a while loop. And what I'm going to check is if the row and the column is in self.body. And then inside of that, if this while loop is triggering, I want to reassign both the row and the column. So literally all I have to do is copy all of this, paste it in here. And then essentially what we are going to do is in here, we are creating a random row and column number. And then we are checking inside of this statement here, if this position is inside self.body. And if that is the case, we are creating a new coordinate. And we are going to keep on creating this new coordinate as long as this row and this column are inside of self.body. So once they're not inside anymore, we are stopping this while loop. And then once we have that, we are setting the position of the row and the column. So with that, we make sure that the apple is never going to be inside of the snake or outside of our game field. So now I can minimize this method here and not think about it again. Actually, display game elements we can also minimize because we don't use it anymore. Now with that, we have drawn all of the game elements. So with that, we can finally come to the actually interesting part of this game, that we are getting user input and use that user input to move the snake. And let me explain how this is going to work. And to make all of this work, we need to understand one key concept, and that is called a game loop. And if you have followed my Pygame tutorials, this should feel fairly familiar to you. But let me explain it if you haven't followed those tutorials. A game loop is essentially how all video games are going to work. And it essentially consists of 3 different parts. Number 1, we are getting some user input. So in our case, we're pressing one of the 5 buttons. Number 2, we are using that input to calculate where stuff has to be on the screen. So for example, if we are pressing right, our snake keeps on moving to the right. And then finally, after we have all the information where stuff needs to be, we are drawing everything. So in our case, we are drawing the new position of the snake and the new position of the apple. And then this we keep on doing forever. So after the loop finished once, we keep on going all the way back to the start. We check again the user input. We then use the user input to get a new position of the snake. And then we are drawing all of this. And we keep on doing this as long as the game is open. So we're only really going to stop this if the player fails the game. And I guess then the really important question is going to be, how can we create this game loop in Excel with Python? And it's actually not all that difficult. In the most basic sense, we are just using a while loop. And this is going to be while true. So this is going to run forever. But this while loop by itself would be way too fast. So we have to slow it down. And for that, Python has another module. It's called time. And this module has the sleep method. And this one can, well, make our code sleep for a certain amount of time. And this we can then use to slow down our while loop to give it a certain kind of speed. And well, that was quite a bit of talk. Let me actually implement it. Here we are back in the code. And the first thing I want to do is to create a new method. And I've called this one, let's call it run. Doesn't need any arguments. And in here, I just want to run while true. And for now, let's just print game. And now further down in the code, I can run snake.run. And if I run this, we are going to see this statement printed a lot. So if I run this, we get a lot of game in our output. So, well, at least we know it's working. Now the problem is that all of this runs way too fast. So if we were to update the snake position every single time this one loops, our snake would move something like 100 cells every second. So not something we can work with. So we have to slow this one down. And for that, we have to import another module, or one part of a module. And this one is from time, import sleep. And all that sleep really does is that it pauses our code for a certain amount of time. And how long that is supposed to be is defined by our speed. So essentially what I want to do is inside of this while loop, I want to run sleep with self.speed. So now if I run this, we can see our Excel file and nothing happens for now, but there we can see. We have one game, if we wait a bit longer, we get another game, and eventually we get another game, and there we go. This is going to keep on going. The problem we have right now is that whatever integer we pass in here, our code is going to be paused for that amount of time in seconds. So right now we would wait 3 seconds for this while loop to continue, which for the game would be very slow. So instead what I have done is our speed is going to be 1 divided by the amount of speed. So in our case right now, our speed is 3. So our actual game speed would be 0.33. And then the higher this number would be, let's say if it is 5, then the pause we would make between each while loop would be 0.2. And that way, the higher our speed is going to be, the faster our game is going to run, which is exactly what we want to achieve. This sleep is only going to sleep our code for 1/3 of a second. So now if I run all of this, this feels like a much more natural speed for our game. So this is going quite well. Cool. So now we can continuously update our game. Next up, we have to get our player input. And let me explain what we are going to do. And actually, let me run the code. So essentially, every time we are running this while loop, I want to get what field we have selected. So right now, I have selected the up cell, then the left, then the down cell, then the right cell. Right now, I have the quit cell. And I want to get the position of the selected cell. And then depending on where this selected cell is, I want to do something in my code. So if the up cell is selected, I want to move my cell upwards. So essentially, I have to find some code to figure out what cell I currently have selected. And this I'm going to do in another method. And let's call this input. It needs self and nothing else. And to get the selected cell, we need self.book.selection.address. And this is going to give us whatever cell we have currently selected. And let me print what we actually get to see what we get. So instead of printing the game, I want to run self.input. So if I run this now, we get A1 because right now we have A1 selected. But if I click on up, we get D11 because D11 is the cell we are working with right now. The same for quit, this would be M14, and the head of our snake right now would be F5. So this is working quite well. So I can close all of this, and with that we are getting an error. Let me close it, but the error we only get because we are trying to get the input while we are getting a cell. So that's just something we have to live with for now. But we are going to fix this later on. Now, this address I first want to store in a variable. So let's call it selected_cell. But there's also another problem, because if you paid attention, when we got the cell, we didn't just get a 1 or something like that, we always had a $sign between them. And this I do want to remove. So I'm going to add a replace method afterwards, because this address is just going to be a string. So we can run one string method, which is called replace. And replace just takes a character we want to remove, in this case a $sign, and then what we want to remove it with. In our case, just an empty string. So now, if I print my selected cell again, I get A1, I get F7, E12, and so on. So depending on what I have selected, I am getting different kind of output. And this we can then check, for example, if I'm on the up key, I want to do a certain thing in my code. So this is already working really well. And again, we get the error code. That's kind of annoying. And actually, while we are at it, we can implement the exit button. And the exit button, I want to have in a separate method. So let's call it exit game. It needs self and nothing else. And what I want to do in here is to get my selected cell again. And now, really, all I want to check is if selected cell is equal to self.myExitCell. So what I specified in board setup, it was this self.exitCell in here. If this is the cell I have selected, then I want to end the game. And ending the game is going to consist out of two separate parts. First of all, I want to get myself and the book, and then close it. And let me actually run this. This should work, although it should give us an error message. So now, if I click on quit, it's not going to work because I forgot to call this exit game in my while loop. So self.exit game, and now let's try this again. So now if I click on quit, our game is going to end. But now we're getting an error message. Quite a long one, but let me explain what the problem here is. So the problem is, after we have run this code, our book has been closed. But that doesn't mean our code has ended, and that's really important. because this while loop keeps on running. But now, since we closed our Excel book, none of this is going to work anymore because we don't have an Excel file to work in. And as a consequence, we are going to get an error message that Python tries to work with Excel, but we don't have Excel open anymore. So essentially what we have to do is we have to close the while loop. And this we could do in two different ways. One could be we could replace this true with some kind of variable, and once we are calling this, we are changing this variable to false. But this would mean changing quite a few things. So instead, I'm going to do something else. And this is going to be another module. So I want to get from sys import exit. And if you have ever used Pygame, this should be a very familiar line. Essentially, sys is a system module that you can use for lots of system functionality. And exit is a command that terminates any kind of code. So once you run exit, you usually terminate whatever code it's run in. And this is exactly what I want to do. So I just want to call exit. And this would end all of the code we are running. And this would also include this while loop. So now if I run this again, we can see our game is still working. Now if I click on quit, everything's stopping, our code is finishing, and we are good to go. Cool. So I guess I can remove this comment here, minimize the exit method, and we are good to go. Now, you might be asking, why not combine the input and the exit game? Because in both cases, we get a selected cell. And I will come back to this at the end of the code. But in the most basic sense, it is really important where we are running code inside of this while loop. So our game could change if we run input before or after our sleep method. So if we run input here or here is going to change how our game is going to work. And same with game. So if we run this before or after self.sleep is going to change how our game is going to work. And in the worst case, it might even crash the game. So we have to be careful here. I'll demonstrate this later on in a bit more detail. But essentially what I want to do is I want to run self.exit game before we have sleep, and then I get the actual input. And I show you later how it's going to look if we change this. It's quite a drastic effect, you'd be surprised. But alright, with that, I want to actually move the snake. So let's talk about how the logic of the snake movement is going to work. And I could actually do this straight in the Excel file. So let me open it again. And let me scroll in a tiny bit. Now, right now, our snake consists of 3 different cells. Let me call them 1, 2, and 3. And every single time this while loop is running, I want to move all of this in a certain direction. And essentially what that means is I want to get my first cell and move it in a specific direction that we are going to define depending on what input we have. So if the input is going to the right, we will move this first cell to the right. If it's up, we're going up, and if it's down, we are going down. So with that, I am moving the head of my snake. So let's say for the sake of the example, I'm going to move my head to the right. But the problem is now, how can we move cell 2 and cell number 3? And the answer here is actually quite simple. Essentially, all I'm going to do, I'm going to take cell number 2 and move it where cell number 1 used to be. And then the same for cell number 3. I'm going to move it where cell 2 used to be. And that way, even if our head were to move downwards, so let's say if our head moves here, eventually the cell behind it would also move downwards because it always follows where the next cell was going to be. So I hope that makes sense. It's going to make much more sense once I actually implement it. And let's do that right now actually. Okay, so first of all, I have to get a direction. And the direction is just going to be a tuple. So in my init method, self.direction. So right now, for example, my direction could be 0 and 1. And just like with our actual body positions, the first item inside of this tuple is the row, or well, y, and the second one is going to be x, or the column. So right now, in this case, we will move the snake to the right. And now that I have that, I can create another method. And let's call it move snake. It needs self and nothing else. And in here, I want to do a couple of things. First of all, I want to copy the entire body. So new body is going to be self.body, and we just copy with the indexing operation all of the body cells. So right now, we are just copying this entire body. Now, next up, I want to get the position of my new head. And all I'm really going to do here is I'm going to get the first item in my snake and then add the direction towards it. And this I've put in another method just to organize this a little bit better. So in here, I've created another method that I called add direction. And this one takes new body and 0. So this item here essentially, and then our current self.direction. And we are going to create this method in just a second. But first of all, I want to get my new body again and then insert this head into it. So this is going to be my new head, and this new head has to be in a position of index 0 in this new body. So this is going to be 0 and then the new head. And then finally, self.body is just going to be the new body. And this way, we are first moving our head in a certain direction. Then next up, we are inserting this head in the first position of our body. So this way, the previously first item, so the head, would now become the item before that. And then we are doing this for all of the cells. So what we have to do now is to actually create this add direction. And this is going to need self. We are going to need our cell, and we need a direction. So these are the two arguments we passed in here already. And really, all I want to do in here is to get a new row and a new column, and then return the row and the column. And well, for the row, all I want to get is the cell and the first index of that, and towards that add the direction and the first item of that. And now I can just copy all of this and change this to a 1 and a 1. And this might seem quite complicated, but let me explain. Essentially, all we are really doing here is we first get this first item of self.body. This one has a row and a column, and towards that we are going to add our direction. So essentially, I'm going to take this row here and then add this number to it. And then I'm going to do the same for the column and add these two numbers together. And this is going to give me my new position of the head. And this is what, let me minimize those methods here. And this is then what these two methods are going to do. So this is what the entire method here is for, and we are using this one in this line. Now, next up, then we are going to insert this new head in the first position of our snake. And that way we are getting a new head. And then the cell that used to be the head is now the first part of the body. And well, all we have to do now is to actually call self.moveSnake. So this way we will get the input and we'll be moving our snake. However, now we do have a problem. Let me minimize those two methods for now, because the problem is we are not actually drawing a new frame. All we have done so far is in our init method, we have drawn the snake. But after we have updated the snake, we are not redrawing all of this. So, well, what we have to do is to cut this display game elements out of here and place it inside of our while loop. So every time this while loop triggers, we are updating what we are displaying in our game. And well, now let me try all of this. And we are getting an error. That cell indices must be integers or slices, not a list. And the problem is our display games. And I actually just saw what the problem is. That for this new body insert, it's not new body, it's new head. So now let's try all of this again. And now we can see our snake is moving. But we do have a problem that the first part of the snake doesn't disappear. So let me close all of this. And the problem here should actually be quite obvious, that we are first copying the entire part of the snake. Then we are giving a new direction and we are adding a new part. So we always add a part, but we don't remove a part. And because of that, our snake keeps on growing. Now, this is actually very easy to fix, because when we get the new body, we don't want all of the body. Instead, we want the entirety of the body minus the last part. So now let's try all of this. And our snake keeps on growing again. And that is because now we have a different problem. So our snake body does work. At least as long as we don't eat anything, the snake body always contains 3 cells. The problem instead what we have is we are drawing over all of these cells. And after we have left these cells, we don't redraw them to the background color. But in reality, we are just drawing on a certain field and we don't change that color back. So that's something we have to work on. So let me close this again. And what I want to do now is I want to get the lost, let's call it the lost cell. And the lost cell is just going to be self.body and -1. So the one part we have gotten rid of earlier. And now what I can do is to get my self.sheet and then get my lost cell and change the color back to my board color. And now let's try all of this again. And there we go. Now we have a snake that moves properly. And let me move this line of code all the way to the bottom. I guess that is the most logical setup. Yeah, whatever works for you. So now if we run all of this again, the snake is looking pretty good. Cool. So that is working very well. So now all we really have to do is, given on what input we have to change this self.direction. And this happens in our input method. So let me minimize the other parts and let's open the exit part again, because we are going to do something very similar. So in my input method, all I really want to check is if my selected cell is equal to, for example, let's start with the right cell. And if that is the case, I want to change my self.direction to 0 and 1. The 1 we already have, because by default our snake is moving to the right. However, now I can add an elif statement that if my selected cell is equal to and let's go with the left cell here. And if that is the case, self.direction should be 0 and -1. And I guess we haven't done an exercise in a while. So what I want you guys to do is to also add the if statement for up and down movements. And that's going to be very similar compared to what we have already done. All right, so all I really need is another elif statement, and if selected cell is equal to self, that's a terrible spelling, let's go with up cell. And if that is the case, self.direction should now be -1 and 0. And finally, I guess we have the down cell. And if that is the case, it should be 1 and 0 for the direction. And if neither of these are the case, then we just keep on the direction we previously had. And that is literally all we needed. So now let me try to run all of this code. The snake is still moving. If I press down, we are moving down. And this works with all the different directions. Now right now, we can also move left and right through the snake itself, but that we're going to fix in just a second. Along with that, we can also go over the apple, and it doesn't really do anything. But this is something we can work on, but it's already looking really good. So let me minimize both of these methods. And now we have actually most of the game done. The few more things we need is to check if the snake has hit an apple and if there's some kind of failed state. So if the snake hit itself or the borders of the game field. And both of these are fairly easy to do. Let's start with another method. Let's call this one check apple collision. And really, all we have to do in here is to check if the head of our snake is in the same field as our apple. So this is a pretty simple if statement. So self.body and 0 is the same as self.apple position. And if that is the case, I want to create a new apple. And now in my game loop, I also have to check this, ideally before we are drawing everything. Otherwise, you might get weird results. So self.check apple collision. And now let's try all of this again. We get our game again. And let me go towards the apple. And there we go. Now we have a new apple. And let me try this again, just to be sure. And yeah, this looks pretty good. Now with that, we have one problem. That our snake is not growing once we are eating an apple. But this we can fix actually quite easily. And let me open the move snake. So right now, we are running this to destroy the last part of our snake when we are moving around. And all the logic we really are going to need is that if our snake has collided with the apple, I actually want to keep that last part, at least for one loop of our game. And that way our snake would be growing by one cell once we are eating an apple. And to implement that, once we're eating an apple, I want to have a new method that I called self.eaten. And once we have collided with an apple, this should be true. And in our init method, let's add this here, self.eaten is going to be false. And now in our moveSnake method, I can check if self.eaten is true, then I want to grow the snake. So here I want some new code. And then if that is not the case, so if we're just moving around, I want to do these 2 lines of code. Actually, let me remove the white space here. So in here, I can also add changing the background color, because this we only want to do if we are destroying the last part. However, if we are not doing that, then the new body is just going to be self.body, and we are getting all of it. And once that is the case, self.eaten is going to be false. And well, now let's try all of this and see if it's working. So the snake is still moving. That's looking good. And if I had an apple, it's growing by 1 cell. And this keeps on working. Nice. Okay, and this is then getting pretty close to an actually working game. Now I guess, let me go through this really quick, because I think the move method of the snake is the most complicated part of this tutorial. But essentially, all we are going to do is, if our snake has eaten the apple, then we are copying the entire body of the snake, and to that, down here, we are adding one more field. So our snake is growing by 1 cell. And then we are setting all of this as the new body of our snake. Now, if that is not the case, so our snake has not eaten the apple, we are not getting the entire body. Instead, we are only getting the entire body minus the last part. And then where the last part used to be, we are drawing that cell in the background color. So that way it disappears entirely. And that way we have our snake movement logic. Now, this is probably something you want to go over a couple of times. It's getting slightly more complex. But, well, for our purposes, I can minimize this and not worry about it again. Now, finally, we need a failed state. So let's call it check fail. mean that our snake either collides with itself or our snake is moving outside of our game window. And for all of this, essentially, we want to check where our head is going to be in relation to the game and the rest of the snake. So for example, if we are checking if the snake is going outside of the screen, the player can only move the head of the snake. So all we really have to check is if the head of our snake is outside of the game dimensions. And if that's the case, we are failing the game. And the same is kind of the case to check if the snake collides with itself. All we really have to check in here is if the head of the snake is somewhere in the body of the snake. And that is also fairly easy to get. First of all, I want to be a bit more specific with my variable names. So I want to create a specific head of my snake. And that's going to be self.body and index 0. And then besides that, I also want to get the body. And that's going to be self.body. And this is going to be from index 1 all the way to the end. And you didn't necessarily have to declare these two variables, but they do make our life a bit easier. Because now we have to create a pretty long if statement. And first of all, we want to check if the head of the snake is inside of the body. And well, here Python is really nice, because all we have to check is if head in body. And if that is the case, I want to just close the game. So self.book.close again, and then also sys.exit. And this we could actually already try. So in the game loop, I also want to check self.check fail. And I guess we can also put this before the display part. And well, let's try all of this. And now here, my snake is moving to the right. If I press left, the game ends. And I just have made one error. I only imported exit, not sys itself. So now let's try this again. So now if I press left, the game is just ending. So we know that this is working, and later on I guess I can test this a bit more thoroughly. But this is all we needed to check if the snake collides with itself. Now besides that, we have to add a couple more statements. I want to know if the head of the snake is too far to the left, too far up, too far right, or too far down. So essentially this is going to be 4 different statements. And let's go through them one by one straight in the code. First of all, let's check if the head of the snake is too far to the left. And this we can check fairly easily, because we know the left part of the game field ends at index 0. So once our snake is on top of that, we want to destroy it. And well, all we need here is the position of our head. And of that, I only want to get the column, so the first one. And this, I want to check if this is smaller or equal to 0. And if that is the case, I want to end the game. And of course, this shouldn't be an end, this should be an OR. So now let's try this. And now let me go all the way to the left, and we should end the game once we're leaving the screen. Cool, so this is working. So this is going to cover the left side of the screen. Now with that, we can also check the right side of the screen. And here again, I want to check the first item of my head, so the column. And in here, literally, all I want to check if this is greater or equal than self.width. Although there's going to be a minor problem, but let me run this and you're going to see very quickly what the problem is. So check where the game ends. And the game ended 1 cell too early. And this we can fix by just adding +1. So now if I run this again, we get our snake again, and I can move all the way on the right. However, if I go further than that, the game ends. So this is also working quite nicely. So with that, we have the left and the right side of our collision mechanic. Now finally, we have to do the same thing for the up and the down movement. And this could be a really good exercise for you. So try to do the same collision mechanic for the up and the down movement. It should look really similar compared to the collisions for the left and the right side. Since it is going to be very similar, let me just copy all of this and let me edit here. Now, for this part, we want to check the first row. So this one has to become a 0, and everything else stays the same. So we are checking the row of our snake head, and if this becomes smaller or equal to the index 0, we are crashing the game. And row 0 is the first row. So this should then be quite easy. Now, besides that, for the bottom part, we still want to check the row, and now this shouldn't be the width, it should be the height. And that should be all we needed. So now let's try this. The game is still running, that's always a good sign. If I go too far down, the game ends. And let's try the same thing by going up. And this also works perfectly fine. And well, with that, I can minimize all of this. And we have a fully functioning snake game. So let me play this for a while, and let's see if it is actually working. And I guess along with that, we can also check if the snake can collide with itself properly. So let's try this now. And the game does indeed work. Cool. And with that, we are basically good to go. Now, there's one important thing I do want you guys to think about. And that is inside of this run loop, or specifically in this while loop here. Because where we execute code in here really matters. And I think the most obvious one is if you put the input before the sleep cycle. Now think about what's going to happen. Essentially, we are first calling this input, and then we are making our code sleep for a third of a second. And while this doesn't sound like a big thing, if I run the game now, and it should start any second, there we go. Now, as soon as I press down, there's always this delay between my input and my actual movement of the snake. It's very difficult to see when you just watch the video. But by itself, this is a problem, because we first get input, then we wait, and only then do we make some updates. So this is very weird to play. Hence, we have to keep it after the sleep part. And the exit game has to be before, and let me demonstrate why, although it might be a bit difficult to see. So now let me just quit the game, and let's try this a couple of times. If the exit game comes after the sleep, there's a potential error, some very cryptic error message. And the essential problem here is that we are trying to do too many things at once. So here we're getting lots of input, and here we are using all of that, which, well, causes potentially problems. And this is why you get something like this. I'm not gonna lie, I'm not entirely sure what's causing it, but if you move self.exit game before the sleep part, this is not causing an error. So in here, you do have to play around with the while loop to make this fully work. But it is certainly doable. But once you have all of that, it's actually fairly straightforward. So, well, with all of that, we have a working game. So I hope all of that was helpful, and I will see you around.